Let's go ahead and look at a couple of examples of definite integrals where we're going to use u substitution. And we do have the two choices. We can go ahead and look at an indefinite integral with u and get that work, then resubstitute, get it in terms of x, then go ahead and put it up there and then evaluate the f of b minus f of a. Or other option would be to express the definite integral in terms of u, changing the limits of integration to get them in terms of u. Then we can work the integral and evaluate without ever having to resubstitute. So let's do one each way here so we can see both of those in action. Looking at this first integral, I see I have 1 over some stuff cubed, so a good choice for u would be the stuff in the parentheses, x plus 3. That would mean du would be 1 dx. So I could express this, the dx is du, and I would have 1 over u to the third, so I can express that as u to the negative 3. So I can think of the power rule in reverse. This would have been u to the negative 2, but then we need over the reciprocal of that power. And now I am going to, actually let's write this, moving this u down to the denominator. Let's write that in terms of x. So u is x plus 3, so this would be negative 1 over 2 times x plus 3 squared. So that's what this integral will be, except that it then needs to be evaluated. So this I'm going to go ahead and put up here, but it needs to be evaluated from 0 to 2. So I have negative 1 over, putting a 2 in, 2 plus 3 is 5, squared is 25, times 2 is 50. And then minus a minus will make a plus. 1 over, putting 0 in, we have 3 squared, which is 9, times 2, which is 18. So our final answer, we just need to go ahead and combine those two fractions. And it looks like that's going to be 8 over 225. Now our other option would be, let's go ahead and do a u substitution, but let's change our limits of integration so that we don't have this resubstitution. So I see here that I have a sine to the fourth and then a cosine. Because the sine is to the fourth, that's a good indicator that I'm going to let u be sine x. Then if I do du, I get cosine x dx. And then I say, oh, that's a good thing because there's my du sitting right there. So this is the integral. Here is u to the fourth du, but now I'm going to put my limits of integration on there in terms of u. So if x was 0, my u would be the sine of 0, which is 0. If x was pi over 2, then my u would be the sine of pi over 2, which is 1. So if I work this, I have u to the fifth over 5 for an antiderivative, and then I'm going to evaluate that from 0 to 1. So that's just going to be 1/5 minus 0, or 1/5.